The Earth is very old, in fact about 4.5 billion years of age, or sometimes 4.6, but the difference doesn't matter much. What I'm trying to point out is that with this age of the Earth, it is no doubt that the fossil records, phylogenetic studies, the genes and genomes, and biogeography have a lot to tell about the Earth's history, where one of the main highlights is none other than evolution. If we look closely at the geological timescale, we can see the eons, eras, periods, and epochs that are subdivided depending on the several factors such as occurrence of mass extinctions, drastic climate changes, the significant changes in the rock layers, geography, and a lot more. If you're wondering where are we now in the geological timescale, well, technically we are here, in the Holocene epoch, which started at the last ice age and lasts for about 11,500 years now. But geologists and conservationists and all sorts of scientists concerned with this discipline debate whether it is reasonable to call it a day for the Holocene epoch, and that we are now in the beginning of a new epoch, which they called the Anthropocene, or the age of mankind. Human influences have impacted the majority of the Earth's biological systems, from ecosystems to the geochemistry of the Earth, from the atmosphere to the oceans. Looking back at Earth's history, there was no other animal or any species that has caused what they call the Great Acceleration, where carbon dioxide emissions rise rapidly, resulting in global warming, habitat loss, mass extinctions that before were only due to natural causes like volcanic eruptions and asteroids hitting the Earth, in a wide-scale natural resource extraction. Our species, Homo sapiens, had only existed 200,000 years ago, but the way we changed the natural systems on Earth is profound. Indeed, the evolution of humans is a major and debatably an irreversible transition. But how can we really say if you're about to shift in another epoch? Well, scientists can confirm whether we are in a new epoch if there are already significant changes in the rock layers, whether it would be in the mineral composition or the appearance of distinct fossils. For this reason, geologists would still disagree that we are no longer in the Holocene. But it is important to note that we are currently experiencing the signs of a new epoch, which appears in the following. Number 1, our climate. Phil Gibbard mentioned that humans are prolonging this warm period that we are in right now. Second, landscape changes that are brought about by our agricultural practices, urbanization, deforestation, and pollution. And third, acceleration of global warming caused by the human activities, particularly that of the burning of fossil fuels that started at the beginning of the Industrial Revolution. With all these massive changes humans incur in the Earth's biological systems, have you ever wondered what the future humans would look like in the next millennia? Well, what we can do now is only to predict, using the principle of evolution by means of natural selection, which Charles Darwin was famous for, that through time, there would be small, gradual changes in the genes and human physiology, and if beneficial, are preserved. These slight changes could eventually aggregate and make the next modern humans very distinct from what we are today. One could also argue that maybe there wouldn't be much of a difference, but still, everything is hypothetical. One thing is for certain is that humans, just like any other species, would continue to adapt to the changing environment in order to survive their lineage, to pass on their genes to the next generations. Otherwise, they would go extinct. Speaking of genes, did you know that we also carry fossils up until today? Not the fossils that were mineralized under pressure and layers of sediments, but molecular fossils that tell a lot about our history. Molecular studies that introduce the gene sequencing methods allow scientists to unravel stored information that tells a lot about our ancestors' history. This is now what we call evolutionary genomics. Advanced genetic engineering methods allowed scientists to perform ancestral sequence reconstruction, where they conducted reverse engineering that allowed them to literally reconstruct pseudogenes in the human genome that are millions of years old. One of our biggest takeaways from evolutionary genomics is that our genome is a historical record itself that preserves our evolutionary legacy through various sequences that make up our DNA. With the present technologies and with our wide knowledge of the Earth's history, biogeography, and evolution that we gained throughout centuries, it is not surprising that we, modern humans, have the capacity to apply these and to induce great changes that would allow us to protect our only home. Whether we are in the Anthropocene or not, This does not change the fact that modern humans had inflicted so much damage and alterations on the Earth's natural systems. Though some might be irreversible, it is still never too late to preserve what needs to be preserved.